Thank you for everybody in the audience for participating today and joining in. Really excited for this conversation. We know that obviously LTE-M is a hot topic in today's IoT world, and there are a lot of advantages that are being promoted, and a lot of this new network offering has a lot of promise for IoT solutions. But it doesn't come without some hair, as new technologies do when they get rolled out. There are things that are initial challenges and things that will be permanent challenges. And so today we're going to talk about what some of those challenges are going to be and how to best work around some of them so that you can take full advantage of those LTE-M benefits. And so before we jump into that, I do want to take just a quick second to give you an introduction to Aris, who we are, why we are at the table talking about this today. So we are at a high level a technology provider for IoT solution providers. Our headquarters are in California and San Jose, but we do have operations throughout the United States and also the rest of the world in UK, India, and Japan. Our company today is a little over 300 people and heavily focused in the engineering and operations space. We really try to focus on providing innovative solutions around some of the technologies that are being adopted in the IoT space or that are on the horizon. And we do this in really two ways. First is with our connectivity platform, where we act as a bit of a hybrid MVNO, providing network connectivity to IoT solution providers, everything from 2G, 3G connectivity globally to LTE globally to LTE-M. Again, not just here in the United States where we're headquartered, but also globally. With that platform, we do support over 12 million cellular connected units on our networks today. Each, combined processing over 4.5 billion messages, everything from registration events to transactions to actual data and SMS being sent. And then, that's going to be the focus of our discussion today is around our expertise in the cellular IoT space. We do have a mobility platform, for the Internet of Moving Things where we actually can provide some solutions and, more IoT plumbing on top of that. But today we're going to, kind of focus on the cellular extension of what we do and really zeroing in, like I said, on LTE-M. And, those of you're here today because you know of LTE-M, you know that it's there. You may even have some experience with development and maybe even some deployments. And you know everything that's being said about it, the key benefits around the lower module cost, the longer battery life, the better indoor signal penetration, which are all huge for IoT deployments. Obviously, LTE networks were built for consumer smartphones. And for some IoT solutions, that's a great fit. But for a lot of solutions, 2G networks were fine. A lot of IoT solutions, the 2G networks were great, both from a module availability, module cost, throughput requirements, all of that. And so LTE-M is the latest and greatest version to get back towards that, which does mean that there is lower throughput. Devices can only send so much information so quickly, and that means it's not right for all IoT applications. An easy way to think about it is sensors versus streaming. LTE-M is great for sensors, devices that are going to wake up, send a little bit of information, go back to sleep. But certainly not ideal for solutions like video streaming or dash cams or things like that have high bandwidth requirements. And a lot of these things are known, well documented, well promoted in the space by various providers who do provide LTE-M technology or building solutions around it. But today we're going to cover some of the challenges that aren't as widely discussed right now. The first being coverage and looking at the fact that these networks are being built out. Where are they being built out? What are some of the challenges today? What are some of the things that are preventing it from being a truly global seamless coverage footprint like, for example, GPRS was? Then second, we're going to take a look at battery optimization. And while LTE-M promotes and enables a significant battery savings, under the right circumstances, you can get 10-year plus battery life on IoT devices. That's certainly true, but under certain circumstances and considerations. And so what exactly are those things you need to think about in order to make sure that you can maximize your battery life? And then the last one is around network limitations beyond just the throughput limitations in terms of how much data can be sent from a device at any given time, but there are actually some undocumented or at least not widely documented limitations from the network itself, which creates some additional congestion points, which might be difficult to work around. So we're going to take a look at those those limitations as well, and cover some ideas to think about as you go about figuring out how LTE-M is best applied to your business, and if it's best suited for your business and your connectivity needs. challenges around LTE-M coverage. And so what we're going to look at is what some of those challenges are, and then also what can you be thinking about as it relates to your business to be navigating some of these coverage challenges. And the first challenge around coverage for LTE-M is really the fact that these networks are still being deployed. They're still new in the grand scheme of their life cycle. And here in the United States, we're probably a little bit further along than certainly other parts of the world. But each carrier is moving at a different pace, and even here in the United States, a lot of networks are still evolving. And what that does is it creates coverage holes as these networks get built out. Obviously they're going to start not at the same coverage footprint as existing LTE networks or even other 2G, 3G networks. And so while it is a software upgrade to towers to turn them on from LTE to LTE-M, it isn't a process that happens overnight. And a lot of the underlying network operators are still making decisions about how they go about deploying LTE-M and if they go about deploying LTE-M. Here in the United States, for example, AT&T and Verizon have their networks deployed. Sprint is deploying their network, and T-Mobile decided to prioritize NB-IoT over LTE-M. And so, where we went in a 2G, 3G, even LTE world, where every operator had their footprints in footprints built out, LTE-M networks are still catching up because it's still early in their life cycle. The second challenge with LTE-M networks right now is the lack of seamless roaming. Certainly in the 2G, 3G world, roaming was a big part of how devices use cellular networks, and especially for IoT deployment, which in a lot of cases leveraged roaming relationships to patch together a complete footprint, especially on a global scale. LTE-M networks are starting to become integrated. Roaming relationships are starting to occur, but it did not start that way. Similarly to how LTE, when it was first released, the roaming was not there. So in previous deployments, and for those of you who have 2G or 3G, or who are coming from a world of 2G, 3G deployment, you're used to the benefits of being able to roam, even if at a premium cost. The coverage improvement, the coverage expansion was there. In the LTE-M world, that's not the case just yet. And while we're moving there, as we look to deploy, today, and if you're looking to deploy over the next few months, those roaming agreements might not be in place just yet. Additionally, as we zoom out to look at the global scale, the fragmentation gets even more trickier, to navigate. And basically, a lot of network operators are picking and choosing whether they're going to go LTE-M or NB-IoT. Even some are deciding to use other LPWA technologies instead, like LoRa. And so what we're not going to see anytime in the near future is that single global standard network, like we saw with GPRS. For anybody that's deploying a global solution and needs global coverage, that presents an obvious challenge that is different from the old world to the new world. Now, there is no magic button to make all this happen. There is no magic button to make LTE or LTE-M network connectivity seamless on a global scale. Instead, we have to take a look at what the real landscape is and what can we do to navigate some of these challenges. And so as we look to what can be done, to fill some of these coverage holes, it's important to consider that there is no single answer that is going to be right for every single deployment. And the reality is that a lot of decisions around which networks to use, how to piece them together, how to go about filling in these coverage holes are going to depend on what your objectives are, both in the short and long term as an organization. And so what you'll really need to do is take a look at where specifically do you need coverage and what are the timeframes around when you need that coverage. For example, if you are looking for a shorter term deployment in the United States, one single network may or may not be good enough to meet all of your coverage needs, and you may need to look to see about leveraging a multi-network vendor, somebody that can provide you access to multiple different networks, LTE-M networks, and manage them from a single platform. Often overlooked are the challenges around connectivity management, and simply sourcing different SIM cards from different network providers ultimately might lead to a challenge of how do you seamlessly manage those and how do you reduce your operational complexities if you have to bounce back and forth between two different platforms. So my recommendation would be to go look for somebody that can provide two different networks, for example, that may be able to solve some of your coverage challenges. And especially in the case of a fixed deployment, you can do coverage checks ahead of time and see which network is likely to be be the best offering for you. Meanwhile, you can still manage all that from a single point, a single platform moving forward. In the case where you need shorter term, you're looking at a shorter term deployment on a global scale. And when I say shorter term, I should put some context around what I mean by that. And really, I'm looking at 2019 as shorter term. And then anything longer term is getting into 2020 and beyond, depending on where you are with your design cycle and where you are with your decision-making process. But as we look to what decisions could be made around, filling short-term coverage gaps, 2019 coverage gaps on a global scale, one of the things you want to consider is how can you leverage 2G fallback, especially GPRS fallback, in addition to LTE-M. And there are a lot of modules out there today that do support both LTE-M and global 2G fallback. A lot of network options that can support that. And so what that can do for you is leave 2G, the 2G GSM global footprint as the backbone. Leverage LTE-M where possible, where those networks are. As I mentioned in the global fragmentation discussion, not every network, not every country has decided to move forward with LTE-M at the same pace. And so you're going to introduce the likelihood in the example of a global asset tracker, for example, where the device may spend some time in country A where there is LTE-M connectivity and then go to country B where there is no LTE-M connectivity. But in both cases, there will be 2G GPRS fallback. As those networks on a global scale have not started to shut down just yet. Different operators are turning that corner. For example, we know that here in the United States, AT&T has already shut down their 2G network. T-Mobile still has theirs up for at least the next few years. But on a global scale, those networks are going to be around for the next couple of years at least, region by region largely, and can still present a reliable connectivity option in the short term while LTE-M networks are being built out. Longer term, it's easy to look at some of the other promising technologies that are being promoted, specifically around EUICCs and subscription management capabilities, where you can have different multiple carrier profiles on a single SIM card and be able to manage how those work. It's a nice bridge into the next conversation, which is around battery optimization. Really, it's one of the key benefits of LTE-M. It's one of the key possibilities, I should say, around LTE-M because it doesn't necessarily happen automatically. And there's a lot of things to consider that, if not thought through properly, could actually result in a very poor battery life for your devices. And so what we'll do is we'll take a look at some of the challenges around battery life, some of the things that you want to be thinking about as you figure out what's best for your solution and what some of those potential solutions might be for you. So we know, as we said, LTE-M does offer better battery life, but it is continually written about under the right circumstances. You can get 10-year battery life with LTE-M deployment under the right circumstances. And really, the battery is possible because of the nature of LTE-M. What it does is it reduces the download and upload links. As I mentioned before, limits the throughput on these devices. 1 megabyte per second. It can only send so much information so quickly. Now, the smaller that pipe, the less power it needs to power the data going up and down there. So naturally, that obviously enables a longer battery life. But the real power savings can come from the power saving mode, the sleep mode, effectively, that LTE-M devices, LTE-M technology, LTE-M network supports. And so, again, it's not so much about these are really kind of the two key factors as to how devices on the LTE-M network can have less battery draw to power their transmission and activities, but it doesn't necessarily happen automatically. Because application behavior and your call flow designs play a very, very large role in whether or not devices can take these benefits of the reduced download and uplink and the power saving mode. Can it actually take advantage of that so that devices can receive much better battery life? Again, it is not just necessarily a simple use LTE-M, use the LTE-M module, pop an LTE-M signal in there, and then everything is automatically 10-year battery life. You really have to think through what is your application behavior and what are your call flows to make sure that you are actually taking advantage of those things and able to actually achieve a 10-year battery life. So let's look at some of the solutions or some of the things that you can be thinking about. power savings isn't guaranteed. There's a lot you can do. Some of this is, this of the three, this is probably one that you may be saying, well, of course, right? Obviously, we know this, but it's worth bringing up and talking through because it's often overlooked. And so, one of the things that we like to do with our customers as we are building out LTE-M deployments with them is take a look at their call flows in depth and figure out ways where we can tweak things, optimize things, and find ways to send, not only just generate less activity from a power saving standpoint, but less activity also means less data transmissions, which means a lower monthly cost for you. And so as we think about how we optimize devices, to take advantage of these power saving benefits, one of the questions that we ask is how can we keep this in the power saving mode as often, as frequently as possible? Certain devices, and this really depends on what is the objective of the solution you've built. For example, if it's an asset tracking solution versus a tank monitoring solution, the frequency at which that information needs to be sent is fundamentally different. And so based on how much information you need, how often you need to see it, what are your objectives as a business? And that's really where we want to start is as you look towards minimally, in a useful exercise is to kind of map out, okay, in a perfect world, we'd love to receive X amount of information on Y intervals, right? Every 5 minutes we want this, or every 10 minutes we want that. Take it back to the other side as well. What is the minimal amount of information that we could use and still add value to our customers? And it's never, you're not going to end up on either one end of the spectrum, but you're going to find somewhere in between. But the more that you can minimize the activity, minimize the data, minimize the reporting, that is what's going to enable the maximum battery life savings. Now, if you find yourself saying, well, that doesn't work for me because I need more, it has to, my solution is dependent on the frequency of the information, then the 10-year battery savings of LTE-M might not be achievable for what you need. And so, are there other ways to think about how to, generate power to that device from a different source? Are there other ways that we can, you can think about maybe that means LTE-M is not the right solution for you. All of those things are possible, and being honest with yourself as you have these conversations and think through it, that's what's going to help you figure out how much battery life you can actually get with these devices. The last one, and this kind of gets into the next conversation, is around, in the last bullet point there is what I'm referring to, how can you increase the connectivity efficiency? Now, anybody that's deployed a cellular-based deployment or a cellular-based device in the past knows that cellular networks are not perfect. There are issues. There are a lot of times when the network goes down. There are times when the device has an issue, whether it be a firmware bug, an antenna misconfiguration, a truck gets parked in the wrong way in front of a fixed device and it loses signal. All of these things are real-world scenarios that are impossible to predict. And so one of the things to think about is knowing that these variables will be introduced as you deploy your solution, knowing that there are times when signals might not be, devices might not be able to connect, or there might be connectivity issues. What is your device doing at those times that may be wasting battery? For example, if a device is programmed to send information at a certain interval, every 5 minutes, every 10 minutes, every hour, when it loses signal, what does it do? And the retry algorithms that are in that device, does it have any back-off algorithms, for example, to say, if I go 3 attempts without sending anything, let me wait, right? Let me wait an hour, let me wait 2 hours, whatever it might be, and then I'll try again. Especially in the case of a moving device, maybe it's in a temporary place where there is no signal. It doesn't make sense to continue to try to hammer the network to send information through when it doesn't have signal, because that's just wasting battery. So all of these corner cases and things like that, have you thought through what you want to do to the device behavior to tweak it so that it can not waste battery power when it's not able to connect? As we look at the next subject around network limitations, what we're going to see is that network congestion, especially at the cell tower site, is a larger problem in LTE-M than it has been with any other technology previously. When devices are congested at the cell tower, what are they doing in terms of wasting or optimizing their battery? And when you need to send something down to the device, an update, a firmware update, whatever it might be, is that device ready to receive that? and is it draining battery unnecessarily when it's having issues receiving that download. Again, this is where some of the corner cases of the network, how it performs, how devices perform on the network, can actually have a huge impact on battery. And thinking through these and coming up with algorithms and whatnot that may sit on the device, intelligence maybe at the connectivity management layer of how to optimize performance to reduce battery life or battery drain, these are all important things to think about how they may apply to your solution specifically, because it isn't just about LTE-M is lower battery, therefore I will get lower or longer battery life for my solution. It's far more complicated than that. All right, so hopefully some things to think about there. And again, the last topic that I want to get into and spend a little bit more time on is around the network limitations, because this is a challenge that, as these networks were being built out, as the standards bodies created these. This one was a bit of an issue that didn't get a whole lot of attention early on, and a lot of the focus naturally went to the lower module costs and the better indoor signal penetration and all the things we talked about. But the network congestion issue is something that's come up and that we've seen as we started to deploy with customers, and something that we've had to figure out ways to work around, because it will be a challenge for LTE-M deployments. And so, the throughput limitations are by design, right? Reducing the amount of data any device can send at any given time is by design, and part of what the benefits of LTE-M are driven by the fact that this is built for sensors and IoT devices, not consumer smartphones that send a whole lot of data. But in addition to the throughput limitations for the device itself, what we've seen, as I mentioned, network congestion is starting to become a concern. Given the fact that the carriers have architected their network so that only a certain pipe of spectrum is used for these LTE-M deployments, it can mean that when things need to be pushed through the pipe in volume, that can be a problem. And when we talk about the congestion, it's not so much traditional cell tower congestion, although that's always going to be possible and always going to be probable, always will at some point be an issue. If you go to a large sporting event and there's 70,000 people all in the same area, chances are it's going to be hard to get transmissions through because of all the consumer cell phone traffic. If you have a connected light at that stadium, a connected anything at an IoT device that's in that stadium, it's probably going to have similar network congestion issues because of the overload at the tower level. In the LTE-M world, we're going to see that become less of an issue than in the LTE world, largely because of the small packet transactions of LTE-M devices and really the type of devices that will be using IoT or LTE-M. For example, sensors are going to wake up and send a small amount of data, very small transmission, likely to get through even in a congested scenario. And that's not what I'm talking about when we get to the congestion concerns that LTE-M presents. Really what I'm talking about is one of the restrictions around LTE-M networks is there can only be so many updates sent down to devices at any given cell tower at any given time. And so, for example, if there are 100 devices, LTE-M devices that are all sensors or all whatever they might be, talking to the same cell tower, you can imagine a scenario in a downtown area of a city, all the potential smart parking, smart meters, smart lights, all of that may be connected to the same cell tower. Collectively and individually, they'll be sending small packets up, and collectively that shouldn't be a major concern. If you had, for example, your deployment yourself had 20 of those devices on that same cell tower right there, if you wanted to send an update down to all of your devices at the same time, that update could be a firmware update. It could be a security patch. You could be sending down an update to the device to enable a new set of features. All of the reasons why you might need to send a remote update down to a device over the air. You can only send so many at a time. The network will only support so many of those going through at any given time. And so if you tried to do 20, for example, all at once, chances are you're not going to be able to send all 20. And you will get multiple failures out of that batch. And that's not even considering how many, of those other 80 devices on that tower are any of those providers, which you will never have any visibility into, Are any of them sending anything down to their devices at the same time? Chances are probably not, but it's possible. And so if you can imagine a scenario now where you've got 100,000 units spread across the United States, if you click send on an update, what's going to happen? In the LTE-M world, the chances are that there's going to be a lot of failures out of that bunch because of the cell tower congestion. So how do you go about managing that? It sounds, and it is, a very, very complicated scenario. Ultimately, you're handcuffed by a lack of visibility. How can you track how many devices are on any given cell tower? How can you know what's the congestion level at that given cell tower? And how can you guess what the chances are that if you send an update to this device, it's going to go successfully or not successfully? The answer is you can't. There's no way for you to be able to know those things and manually track those things. What you should be thinking about is how can you use a connectivity-aware campaign manager to manage those updates down to these devices. Now, anybody that's got a large-scale IoT deployment is going to have some sort of ability to send down updates, not just because you want to and you need to for various security situations or various features, enablements, or whatnot. There are actually regulations coming out. For example, there's a law that's being passed in California where any deployments in California, the devices have to have the ability to execute a remote update. And so anybody, even if you're not based in California, if you as an IoT solution provider want to get a device in the state of California, even if it's just roaming, if it's an asset tracker, it's not there permanently, you're required to adhere to these regulations. And so you're going to have the ability to send down over-the-air updates to these devices, remote updates. And your management processes, there's lots of different ways to do it. You can leverage tools from third parties, maybe device manufacturers who have a campaign management element to their offering. Maybe you decided to build your own, which a lot of large deployments do, to leverage, basically have more control over how to schedule, how to select devices, and so forth. The way that we are thinking about it and what we're working with customers on is how to include connectivity awareness into those campaign managers. For example, imagine a campaign management portal where you can go in and select devices that you want to send an update to. Maybe it's just you want to send an update to a certain make and model of your deployment, a certain region, a certain type of device, whatever it might be, or all of the devices in your fleet in your deployment, and you want to select all of those. And then, is there a way for you to feed connectivity information, network information into that management system so that you know which devices are ready to receive the update based on what they're currently doing? Are they registered on the network? Are they sending data successfully? Are they not sending data successfully? All the network information that is capturable, you can apply logic to the information that you get on any given device and say, okay, based on these 4 factors, it looks like this device is ready to go and it's ready to receive an update. Now we can automate, or you can, go about automating the process to send down those updates through APIs and through automation. You click a button and it's going to automatically check the network information, figure out which devices to send the update down to, track the results of that attempt, see which ones went through successfully, see which ones failed, apply automation retry algorithms at the platform level so that devices that fail for reason X, we're going to wait until tomorrow to send again. Devices that fail for reason Y, we're going to try again right now. All of these things start to become possible when you think about how to take connectivity-aware information, even network APIs that can feed this into either your campaign management system or a third-party campaign management system. Leverage that connectivity awareness to know and create rules around how to more efficiently send these updates down. And again, this becomes huge when trying to combat the challenges that LTE-M presents around network congestion, specifically for remote updates. So again, this is something that we work with our customers to start, thinking about how can they best apply some of these ideas into their campaign management system, however they have it built. If you have questions specific to how that may apply to your system or the way you're thinking about it, please reach out. We'd be happy to answer that question for you based on what we might be able to recommend or suggest. But figuring out a way to get smarter about how to do remote updates is going to be very, very critical for any large-scale LTE-M deployment because of these network challenges, these network restrictions. So hopefully that's a bit of information that that might have been new, maybe you hadn't been thinking about, maybe you were aware but didn't know the answer. But definitely something to think about as you go about mapping out what is it, how are we going to deploy this solution and how are we going to manage this long term. Ultimately, I know that we covered a lot of confusing topics today, and there's a lot of moving pieces around LTE-M. It is unfortunately not a simple technology. As I had mentioned before, the days of a truly seamless, easy, cheap global network like GPRS are not in front of us. They are certainly behind us, and so all we can do is figure out how to adapt our solutions to this changing landscape. There is no one single best answer. There's lots of different options. It really depends on what the objectives of your company are, what your specific coverage and deployment needs are, and what are the best ways for you specifically to go about it. I hope that there was some, indicative guidance, at least in terms of directionally, that might be interesting for you to think through. But certainly happy to answer, offline any other specific questions. The battery optimization, obviously we saw a lot of you were very interested in that potential benefit of LTE-M, and there's a lot more to consider than just LTE-M will give me better battery life for my devices. And a lot goes into the application behavior, how you fine-tune, how you maximize your solution to be best suited to take advantage of a longer battery life, to take the technology and actually turn it into better battery life. There's a lot to consider there, especially from a network connectivity standpoint. How do my devices connect and what are they doing when we're having connectivity issues? That can be a significant drain on battery for devices, and something to think about as you kind of design solutions. Think about the best case, think about the worst case, think about everything in between, and figure out the best ways to tweak your solution to get better battery life. Then the last one, obviously, I spent a good amount of time covering, but the connectivity aware campaign management. Knowing that network limitations, network congestion, especially for remote updates, will be a problem with LTE-M solutions. What can you use to get smart about how you manage those large-scale updates? What information can you get from the network that may help you? How can you create automation to minimize your operational cost of executing a successful deployment-wide update? These are all things that we need to think about in a slightly different way than we have in the past because of these network limitations. And again, not a necessarily single answer for every single person out there, every single solution, but some concepts for you to think about as you figure out the best ways to do this. And ultimately, there's a lot of different directions that you can go with LTE-M, a lot of different solutions that may be right for you that aren't right for the person sitting right next to you. And there is no one silver bullet with this. And so reach out to the people who live and breathe this every day. Come talk to us. We'd be happy just to you can pick our brains, run ideas by us. Happy to take a look, even go even further in depth and do application reviews and suggestions and so forth. We know this is not an easy topic. We know that some of the sensitivities, some of the pressure around 2G shutdowns, 3G shutdowns that are starting to happen more frequently are creating a lot of pressure to move to the next technology. We understand the sense of urgency there. We have a lot of customers that we're helping them go through that right now. We know it's not easy, so we're happy to help any way we can.